Good morning, students. Now we can see inverse Z transform. So this is important formulas used in Z transform. These formulas used to do inverse Z transform problems. So already we have seen Z transform problems in the previous slides. If you have x of n as impulse response, the Z transform is 1. ROC is the entire Z plane. Del of n minus n naught, Z power minus n naught, ROC is entire Z plane. U of n is 1 divided by 1 minus Z inverse, modulus of Z is greater than 1. Minus U of minus n minus 1, 1 divided by 1 minus Z inverse, modulus of Z is less than 1. N into U of n, Z inverse divided by 1 minus Z inverse the whole square, modulus of Z is greater than 1. Minus n into U of minus n minus 1, the same thing but the ROC is less than 1. Okay, so these formulas. Similarly, a power n u of n minus a power n u of minus n minus 1 n into a power n u of n. So these formulas are essential. This one, this one, this one, this one, this formula, then a power n u of n minus a power n u of minus n into this one, this formula. So these are all the formulas needed for inverse Z transform. At the same time, the cos omega naught u of n. So if you take Laplace transform 1 minus Z inverse cos omega naught divided by 1 minus 2 Z inverse cos omega naught plus Z power minus 2, region of convergence is this one. Similarly, sine a power n cos omega naught, a power n sin omega naught. So these are all the things is needed for doing inverse Z transform. Now we can see what is meant by inverse Z transform. Inverse Z transform is defined as x of n is equal to 1 divided by 2 pi j contour integral x of z, z power n minus 1 d of z. This is the formula of Z transform. Okay. How to solve? So the contour in using this formula, we are not able to solve it. Instead of it, we have three methods used to process the inverse Z transform. The first method, long division method or power series method. The second one, power fraction expansion method. The third one, complex inversion integral method or Cauchy residue method. So these three methods used to find inverse Z transform of any signal. The next one, you take first long division method. Find the inverse Z transform using long division method. So the problem is given, x of z is given 1 divided by 1 minus a z inverse. Here very important one is the region of convergence. The region of convergence is modulus of z greater than a. So whenever if they will give like this, okay, so from this we came to know that the x of n is causal sequence or right-sided sequence. So if it is causal sequence or right-sided sequence, what we have to do? We have to do the long division method. The numerator you keep as it is, the denominator you keep as it is. Okay, divide it. This is called the long division. Okay, first you take 1 minus a z inverse. You multiply 1. So what you will do? You put 1, this 1, multiply the whole thing. You will get 1 minus a z inverse. Okay, so you know that these two will be subtracted. Minus get cancelled. Here this minus plus a z inverse, you will get it. Then again you put, to cancel the first term, whatever the first term you have it, that you will get it the second term of here. If this is plus means plus a z inverse. Now you multiply this a z inverse with this value. A z inverse into 1 a z inverse, then minus a square z power minus 2. The first term get cancelled. The next one, minus minus becomes plus, you will get a square z inverse 2. Now the same term you have it here, so you multiply and do it. So the process will go till infinite. So from this, from the quotient, this is the remainder part. From the quotient we can able to the right final answer. So x of n is equal to, within a flower bracket, the first number is the origin amplitude. So you mark it 1, the origin represented by the arrow. The second a, you mark it. Then you have a square. Then it will go a cube, a4 like that. So this is will be the long division method, applying the find the inverse Z transform for the signal this one. The next problem, x of z equal to 1 divided by 1 minus a z inverse, the same one, but the ROC is less than. Less than means the ROC is anti-causal or left-sided sequence. Okay, if it is a left-sided sequence, what we have to do, then numerator and the denominator, okay, the series should have the positive power. So what we have to do, you take this one, the numerator and the denominator, you write it in a higher term to the lower term. Here one only, in the denominator you have like this. So first you take the higher term, then you have the lower term. So minus a z inverse plus 1. Now you do the division. Okay, so one by one you do the division. The final answer can be written as, okay, here no the constant term. The constant term it must come. No constant term. So it take it as a value for the origin. Then from the next one, minus a inverse power 2 minus a power minus 3. Like that the series will go till minus infinity. So this is called if the ROC is less than a. Okay, that is, it is, the problem is anti-causal or left-sided sequence. Now see the another example. Here the ROC is greater than 1. This is causal sequence. So main thing is ROC. If ROC is greater than 1, it's a causal sequence. In this, the same method, 1, the series you write it as it is, do the long division. Okay, after performing the long division, you write down the final answer. Okay, from the each and every constant you write it, you will get the final value. Okay, so from this what we observed means only two part. The ROC is causal and anti-causal. Causal means modulus of Z is greater than modulus of A. A is the pole. Similar, that is causal. Anti-causal means modulus of A is Z is less than A. So if it is greater than, the numerator and the denominator you keep as it is and do the long division. Okay, from the quotient you write down the final answer. For anti-causal sequence, okay, numerator and the denominator you write it in a highest power to the lowest power. Numerator highest power to the lowest power. Similarly for the denominator, perform the long division. Okay, then you will get the quotient. From the quotient you write down the constant value. So this is the procedure to perform the long division method. The next one, inverse Z transform using partial fraction. Okay, all of you know very well about partial fraction method. What is meant by partial fraction? So the partial fraction, the problem is given h of z is equal to minus 4 plus 8 z inverse 1 plus 6 z inverse plus 8 z power minus 2. So first what we have to do, you look at the highest power either in the numerator or the denominator. Here the z power minus 2 is the highest power, so you bring it out. Okay, so convert the z inverse powers into z powers. So you will get this. Once it converted into z power, okay, now divide z on both sides. That is the concept. Once the division part is over, you do the partial fraction. So all of you know how to do the partial fractions. We have seen in the class. So once the partial fraction is over, you obtain the variables a1 and a2, you substitute it, you will get the answer. Is it clear? Once the answer is getting, you take inverse Z transform. We will get, after taking the inverse Z transform, minus 12. So by using the formula, we have seen the previous table. In the table, the formula is given here. So this is minus 4 power n u of n. 8 into, because everything is the right sided sequence. So the whole answer is multiplied by u of n. Now we can see the second problem by using partial fraction method. X of z is equal to z squared plus 2z divided by z plus 2, z squared plus 2z plus 5. So here the given problem is in the z form. Directly you can divide z on both sides. Do the partial fraction. Okay, factorize the denominator. You proceed with the partial fraction. Okay, once partial fraction is completed, obtaining a1, a2 and a3. So the next slides we got it. Okay, take inverse Z transform, we will get the final answer is like this. So this is by using the partial fraction method. Here the same problem we have by using the partial fraction. So find the inverse Z transform of x of z, this one. Okay, first you convert into z form, then divide z on both sides, apply the partial fraction, find the constant, take inverse Z transform. The third problem. Then the fourth problem, the multiple pole is given. X of z is equal to z squared divided by z minus 1, z minus 0.5 the whole squared. Okay, first here you do the already the form problem is in z form. Directly you do divide z on both sides, so you will get this term. Now you do the partial fraction. Okay, once the partial fraction is applied, you find the constants a, b, c. After getting a, b, c, here the direct poles no problem. Whenever we have the multiple poles you have multiple poles, we will get like this. Okay, so from the table we all know that the table it's given like this, you take it. So whenever we have multiple poles, you will get n into, that is a power n u of n. The same thing we have done it, so that this part can be written by this method. Okay, so that is given here. This is for multiple poles. The next one, the same different problems by using the multiple pole is given. So this is also the same procedure we have to proceed it. So see the method, how it is using the multiples, the constants are obtained each step by step. Finally we got the result for the variables, that is substituted here. The final answer is written here.